Probability 5, tree diagrams. So we're going to look at different ways in which we can use tree diagrams and what it actually means when we're calculating chances of things happening. So a tree diagram, we've got a sample on the screen, happens when you are branching from a point of origin or a point of start. We're starting over there and we've got two outcomes according to this. So the first event is binary. Either A happens or B. Then the second event is binary again. We've got A and B again. And then the third one again, A and B. So you can repeat it as many times as possible or as many times as you choose. This could be an example of flipping a coin, heads or tails. This could be the light switch being on or off. This is the probability of you being a boy or girl. So if you're looking at a binary option, we've got A and B as outcomes. Now, at the end, we have a combination of our outcomes in which we follow the line or follow the tree branches to see what are the chances. So we're looking at the highlighted one, ABB. It means first you had outcome A, then you had outcome B, and then you had outcome B. That was the order in which it happened. Please, again, take note that ABB is not the same as BBA, because the order in which it happened is not the same. So when we're calculating probabilities and all things are equal, then we are going to say that the chances of you getting A, B, B, if you look at this is one option out of a total of 8. In the circle there are 8. So probability of that happening is 1 out of 8. Okay, so now let's do a question where it says that a game contains 2 tetrahedral dice which have got 4 faces each, and the faces are numbered 1, 2, 3, 4. The 2 dice are thrown and the total score is noted. Find the probability that the total score is going to be 3. Now, instead of doing total score, because that's one step more advanced, let's do without total score. Let's just do the numbers on the faces. Okay, so if I start at my starting point and I roll the first dice, so event number 1, rolling the first dice, I could get a 1, I could get a 2, I could get a 3, and I could get a 4. That is rolling the first dice. Rolling the second dice, so this is going to be event number 2, I could get a 1, a 2, a 3, and a 4. A 1, a 2, a 3, and a 4. A 1, a 2, a 3, and a 4. A 1, a 2, a 3, and a 4. In total, the number of options available is going to be 4 for event number 1 times 4 for event number 2. So there are 16 total options. So what happens here? My outcomes are going to be 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4. Those are all the possible outcomes. 4 groups of 4 are 16 in total. If I did want to go back to finding the probability of a total score of 3, I would then add them up and say that this one is 3, that's 4. This one is 3, and that's all greater than 3, and that's all greater than 3. So the probability of getting 3 is going to be P3 is equal to 2 out of 16, or 1 out of 8, which is 0,125 or 12,5% chance of getting a number 3 if I add the score of the two numbers together. Next question, find the probability of getting a score that is more than 4. More than 4. So let's have a look. That's 4. So that's 5, 4, 5, and 6. That is 4. So 5, 6, and 7. And here 5, 6, 7, 8. So I've got 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The probability of getting an answer that is greater than 4 is 10 out of 16. So 10 out of 16 is going to be 5 out of 8. 10 out of 16. This is 5 out of 8, which is 0.625, or 63% chance of getting a score that is greater than 4. Which score is most likely? Which one repeats the most? So let's have a look. Let's fill in the difference. That's 2, that's 4. That's 4, that's 4. So the one that happens the most, we've got 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8. Interesting pattern. Which one do they all have? They all have the number 5. 1, 2, 3, 4. So the one that is most likely to occur is the number 5, because all 4 sets happen. So probability will be 4 out of 16, which is 1 over 4, or 25% chance of it happening. Next question. Okay, next question. They're saying a school cook decides at random at what flavor squash to serve at lunch. Squash, for us, we know, but not squash. No, this year they are referring to juice. Okay, so they're saying she chooses from blackcurrant, orange, and lemon. Complete the table. Because we're doing tree diagrams, we are not going to do a table. We are instead going to do a tree diagram. So complete the tree diagram. Option number 1. So we've got 2 days, right? Event starts, and on day 1, our options are 1, 2, or 3. Blackcurrant, lemon, or orange. Then on day 2, our options are 1, 2, 3, 1, 2, 3, 1, 2, 3. Blackcurrant, lemon, orange, blackcurrant, lemon, orange, blackcurrant, lemon, orange. So our outcomes are going to be blackcurrant, 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 lemon, blackcurrant, orange, day 1, day 2. Or you can have lemon, blackcurrant, lemon, 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 orange. Or you can have orange, blackcurrant, orange, lemon, orange, orange. So instead of doing a table, we did a tree diagram. Question B is saying, what is the probability of getting blackcurrant on 2 consecutive days, day 1 and day 2 being blackcurrant? There we have blackcurrant, blackcurrant. The chances of that happening is 1 out of how many? Now again, remember, for us to do it arithmetically, I'm going to say 3 options on day 1. So these 3 multiplied by those 3 gives me a 9 in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting blackcurrant, blackcurrant on 2 consecutive days is 1 out of 9. 1 out of 9 converts to 11% probability. Okay, or 0.11 recurring as a decimal. Next question is asking me, what is the probability of getting the same flavor on both days? So not just blackcurrant, but in doubles. So we've got blackcurrant, blackcurrant, we've got lemon, lemon, we've got orange, orange. So the probability of getting doubles is going to be 3 out of 9, which is 1 over 3, 0.33 recurring, or 33% chance of you getting the same flavor in 2 different days. What is the probability of getting lemon or blackcurrant on both days? So we're going to look at a combination of LB or BL. BL and LB. There are two ways of that happening. So probability of lemon or blackcurrant is going to be 2 out of 9, which simplifies to 0.22 recurring, or 22%. Next question. Claire's allergic to lemon squash. What is the probability that she will not have any squash for 2 consecutive days? So the probability of getting lemon on 2 consecutive days, meaning day 1 and day 2, is just 1. So the probability of lemon is going to be 1 out of 9, which is equal to 0.11 recurring, or approximately 11%. The probability of her not having juice for 2 days in a row is 11% chance. Okay, so those are tree diagrams. I wish you all a great day, and I will see you in class. Please like and subscribe. Bye-bye.